The convergence of artificial intelligence, AI, and neuromorphic computing is a thrilling development at the intersection of technology and brain science. This fusion is not just about making computers smarter, it's about reshaping them to think and process information more like the human brain. Understanding AI and neuromorphic computing. AI involves creating machines or systems capable of performing tasks that typically require human intelligence. This includes things like recognizing speech, learning, decision-making, and problem-solving. Traditionally, AI systems process information through algorithms running on conventional computer architectures. Neuromorphic computing, on the other hand, is an area of technology inspired directly by the structure and function of the human brain. While traditional computers use a digital architecture of zeros and ones, neuromorphic systems mimic the neural structure of the human brain. They use networks of artificial neurons and synapses to process information, which can lead to more efficient and adaptive computing. Convergence of AI with neuromorphic computing. When AI meets neuromorphic computing, the potential is significant. AI systems can become more efficient, needing less power to perform complex tasks. They can also become better at learning and adapting in real time, much like the human brain. Opportunities. Energy efficiency. Neuromorphic systems can perform complex computations using far less energy than traditional computers, which is crucial for making advanced AI more sustainable and accessible. Real-time learning and adaptation. These systems can learn and adapt in real time, much like humans do. This is particularly useful in robotics and autonomous systems. Advanced pattern recognition. Neuromorphic computing can enhance AI's ability to recognize patterns and make decisions, leading to advancements in areas like medical diagnosis, surveillance, and autonomous vehicles. Concerns. Ethical and privacy issues. As AI systems become more advanced and integrated into daily life, concerns about privacy and ethical use of technology become more pressing. Security risks. With increased intelligence and autonomy, ensuring the security of these systems against hacking or misuse is vital. Understanding and control. As AI systems become more complex and brain-like, understanding their decision-making processes and maintaining control over them can become challenging. Pop culture examples. Data from Star Trek, The Next Generation. Data, an android with a positronic brain, is an example of what neuromorphic computing aims to achieve. He processes information and learns much like a human, showcasing the potential of advanced AI. Ex Machina and AI consciousness. The movie Ex Machina explores the idea of a humanoid robot with advanced AI, capable of learning and evolving. This echoes the goals of neuromorphic computing, to create systems that can adapt and learn from their environment. Real-world implications. Imagine a future where your smartphone learns and adapts to your usage patterns using minimal energy, or robots in a factory that can learn new tasks on the fly without needing to be reprogrammed. Neuromorphic systems could make these scenarios a reality. In healthcare, neuromorphic computing can revolutionize the way diseases are diagnosed and treated. AI systems could process medical data to identify patterns and suggest treatments, learning and adapting with each new case. In environmental monitoring, neuromorphic systems could continuously learn and adapt to changing conditions, providing more accurate and timely data for decision-making. Conclusion. The convergence of AI with neuromorphic computing holds the promise of creating more efficient, adaptable, and intelligent systems. While it presents challenges and concerns that must be carefully managed, its potential to transform technology and society is immense. We are on the cusp of a new era where machines not only compute but also learn and adapt in ways that are remarkably human-like.